In this lesson we're going to be factoring quadratic functions. This is section 5.4 in Algebra 2. What is factoring? Factoring means that you are undoing the multiplication process. When you factor a polynomial, you're essentially just starting with the answer and you're trying to work backwards to what it looked like before it was multiplied together. For example, if we started with the polynomial x squared plus 4x plus 3, factoring means we'd be working backwards to what the factors were that were FOILed in order to give us that answer. X plus 3 and x plus 1 would be the factors that would give us x squared plus 4x plus 3, so these would be called the factors of that polynomial. When you factor a polynomial, you want to go through a specific order of things to look for. I put them here in this checklist, and I want you to refer to this checklist anytime you're factoring a problem. The first thing you always look for is a greatest common factor. Whether you have a greatest common factor or whether you don't, you're still going to go through all the other points on your checklist. It's just a matter of whether you have taken out that greatest common factor and continued on to your checklist, or said, nope, there's not a greatest common factor here, and then you just go straight on. You never just stop right there and get done with it. The next thing you look for is if you have 4 terms, you look for the grouping method. If you have 3 terms for your polynomial, try the trinomial method. And if your first term and your last term are perfect squares, then try the perfect square method. Now we're going to go through each one of these in depth with examples, but please know that you go through each method and look to see if that applies in that problem. Don't just stop when you get done with one method and say, okay, I'm done, because it's possible to use more than one method in the same problem, and that would be considered factoring completely before you'd be done, and you might have to do more than one thing. The first type we're going through is called factoring by greatest common factor. You always, for every single problem, 100% of the time, start by looking for a greatest common factor. Look at our first example, 4x squared plus 20x. The greatest common factor is what goes into each one of these terms and can be divided out. For 4 and 20, 4 is what goes into both of those numbers. And look also at each term and notice that there's an x in common in each term. So the greatest common factor for both terms would be 4x. This is what I have in common in both of my terms. I take that and I put it out in front of a parentheses. Now I'm going to look at each term and see what's left over. In my first term I have 4x squared. I'm dividing out by 4x, so I have an x left over from that term. In the second term we had 20x. We're dividing out by 4x, so that leaves a 5 left over from that term. X and plus 5 are leftovers. They go inside the parentheses. 4x is your greatest common factor. It goes out in front. Look now at the next example and see if you can identify what the greatest common factor is. Pause until you're ready. The greatest common factor for 25 and 35 is 5. This is the number that goes evenly into both of those numbers and is the largest one. Look also at the variables. We have x's in both terms and we have y's in both terms. Now to figure out how many you have in common, look at the lowest number of x's you have and the lowest number of y's that you have. The lowest number of x's that I have is 2. That's my lowest exponent. The lowest number of y's that I have is 2. That's my lowest exponent. So x squared and y squared will be part of that greatest common factor with the 5, and all of that will go out in front of the parentheses. Now we look at each term and see what's left over. From the first term, when I take 25 and divide out by 5, I have 5 left over. From my 3 x's, 2 are gone, 1 is left, and from my 4 y's, 2 are gone and 2 are left. So first term leftovers are 5, x, and y squared. From the second term, 35 divided by 5 is 7. Both of my x's are gone. Both of my y's are gone. So just 7, no variables left with that second term. The final answer looks like this. 5x squared y squared represents your greatest common factor. Parentheses, 5xy squared, that's leftovers from your first term, plus 7, that's left over from your second term. Try these next two problems, look for the greatest common factor, and pause until you're ready to go through them with me. Okay, on the first problem, our greatest common factor would be 3, not 3x. X is not in common to all three of our terms, it's only in common to the first two terms, so it doesn't count. 3 is the largest number that goes into all of these. When I take that out, I look now for the leftovers. 9x squared divided out by 3 would be 3x squared. 3x divided out by 3 would be x. And negative 18 divided out by 3 would be negative 6. So 3 out in front for the greatest common factor. In parentheses, you have 3x squared plus x and minus 6. On the second problem, 2w is the greatest common factor. I'm going to take it out and put it in front. From our first term, when I take the 4w squared, I'm dividing out by 2w, and that gives me 2w left over. On the second term, 2w divided out by 2w is 1. So I have 1 left over from that second term. Final answer looks like this. 2w in front for the greatest common factor. In parentheses, 2w left over from the first term, plus 1 left over from the second term. Factoring by grouping. If your original polynomial has 4 terms, you want to try the grouping method, and this is how you do it. Group the first 2 terms together, and group the second 2 terms together. Now we're going to essentially do a greatest common factor problem twice in the same question. In our first set, the greatest common factor is 3m squared. That will come out in front of our parentheses of leftovers. In the second set, our greatest common factor is 2. That will come out in front of that second set. Now, I look at each set and I see what's left over. From my first set, when I take 3m squared and divide it out to each term, the first term leaves me 2m left over, and the second term leaves me plus 3 left over. Likewise, in the second set, when I divide both of those numbers by 2, I'm left with 2m and plus 3. Now notice what's left over in the first set is the same thing that's left over in the second set. That's not a coincidence. That should happen every single time you use the grouping method if you're using it correctly. 2m plus 3 represents part of our answer. The rest of our answer will be the things that we took out of each set. The 3m squared and the plus 2. They get grouped together in their own parentheses. And here's how we write our answer. 2m plus 3 goes in one parentheses. 3m squared plus 2 goes in the second parentheses. That double parentheses look is what we're going for in the end. You try the next one, group the first 2 terms together, group the second 2 terms together, and see if you can identify the greatest common factor of each group. Pause until you're ready. In the first set, the greatest common factor is 3x. In the second set, the greatest common factor is negative 2 and y squared. I have a negative in common, 2 in common, and y squared in common. Now I look for leftovers from each set. Going back to the first set, when I take 3x and divide it out of each term, I have x left over from the first term and y left over from the second term. In the second set, the same thing happens. When I divide out negative 2y squared from each term of the second set, I'm left with x left over from the first one and y left over from the second one. So x plus y is left over in each parentheses. Notice that what's left over in parentheses in each set is the same thing, x plus y. That's not an accident. That's going to happen every time or you've done something wrong in your grouping problem. X plus y represents part of our answer. The rest of our answer will be 3x and the minus 2y squared, the things that we factored out already. Here's how we write it. X plus y in a parentheses, and then 3x minus 2y squared in a second parentheses. Double parentheses, look to our answer. Factoring a trinomial, the third thing you should look for in your checklist. A trinomial is something that has three terms to it. X squared plus 8x plus 7 is a trinomial, three terms. Focus in on your n number, which is a 7, and you want to think to yourself, what multiplies together to make 7? Well, the only whole numbers that multiply together to make 7 are 1 times 7. Now we focus in on your middle number, which is an 8. Do 1 and 7 add up to 8? Yes, they do, so those are our factors, x plus 1 and x plus 7. Trinomials are always going to factor into this double parentheses kind of look. Alright, look at the next problem. 40 is our n number, so we look to see what multiplies together to make 40. Make a list, either in your paper or in your head. 1 times 40, 2 times 20, 4 times 10, 5 times 8. Now we look at our middle number. What pair on this list adds up to make 14? Well, that would be the 4 and the 10. So our factors are x plus 4 and x plus 10. Try these next two. Pause until you're ready. Okay, focus in on your n number, which is an 8. What multiplies to make that number 8? 1 times 8 or 2 times 4? Our middle number here is a negative 6. So do we want to pick the 1 and the 8 or the 2 and the 4 to add up to negative 6? Well, 2 and 4 would work, but only if they're both negative. And that's what we want. X minus 2, x minus 4. Both negatives. On the next one, our n number is a negative 10. What multiplies together to make negative 10 would be 1 times negative 10, negative 1 times positive 10, 2 times negative 5, or negative 2 times positive 5. We want to pick the pair that adds up to make positive 3. That would be the positive 5 and the negative 2. So our factors are x plus 5 and x minus 2.